Welcome to Talking Melons for 2020, a series of presentations that brings you a range of topics to assist in growing and marketing Australian melons. The presentations are available on the Melons Australia website as a video, a podcast, and as a slide deck. Visit www.melonsaustralia.org.au.
The Research, Development and Extension Project for Control, Eradication and Preparedness for Vegetable Leafminer, MT16004, has been funded by Hort Innovation using the vegetable, nursery, melon and potato research and development levies and contributions from the Australian Government. The project brings together project lead CESA, the University of Melbourne, Plant Health Australia, the Department of Agriculture, Water and the Environment's Northern Australia Quarantine Strategy, and AusVeg. In this podcast, Elia Pirtle from CESA, along with myself, Maddie Quirk from AusVeg, will provide an overview of exotic leaf miners for the Australian melon industry. Exotic leaf miners are a major pest of agriculture in many parts of the world. They are on the Australian Department of Agriculture, Water and the Environment's top 40 pest list. Exotic leaf miners include potato leaf miner, Liriomyza pedibrensis, American serpentine leaf miner, Liriomyza trefolii, and vegetable leaf miner, Liriomyza sativa. The potato leaf miner and American serpentine leaf miner are not present in Australia, but are found in neighbouring countries including Indonesia. Vegetable leaf miner was first detected on mainland Australia in Sasha, Queensland in 2015. It is currently under quarantine in that region and has not spread to other parts of Australia. Exotic leaf miners in their adult form all look extremely similar and cannot easily be distinguished. Adults range from approximately 1 to 2 millimetre in length and are black with areas of yellow on their head and abdomen. Exotic leaf miners have 4 life stages: egg, larva, pupa and adult. Eggs are laid beneath the leaf and hatch about 3 days later. Then the larvae tunnel through the leaf feeding on plant material for approximately 1 to 2 weeks. Afterwards, the larvae emerge from the leaf before pupating in the soil, and after 1 to 2 weeks, pupae become adults and the life cycle begins again. The most significant damage caused by exotic leaf miners is known as leaf mining, and it looks like thick, silvery white, spiralling tracks on the leaf. This is created when larvae feed by tunnelling through plant material. Adults also create stippling damage, which occurs when an adult female feeds or lays eggs, and it looks like small, white, circular holes in the leaf. There are many host plants from a number of families that are susceptible to exotic leaf miner damage. These include solanaceous crops, cucurbits, brassicas, among many others. Melons are considered at risk of all 3 exotic leaf miner species, in particular vegetable leaf miner and the American serpentine leaf miner. Leaf miners can have an impact at the plant level and at the farm business level. At the plant level, impacts include leaf mining, which disrupts photosynthesis, stippling, which may bring secondary infections, stunted plants, failure to fruit, or even plant death, particularly for young plants. At the farm business level, impacts may include farm quarantine, yield reduction, loss of marketability, and costly pest management, in part due to the propensity of these pests to evolve chemical resistance. Through the Hort Innovation funded project, a review was undertaken to analyse real-world impacts of exotic leaf miners overseas. Losses have been extremely variable, but are highest when the pests have been inappropriately managed and natural enemies are eliminated. In some examples, yield losses have been reported to be as high as 65% in watermelons due to vegetable leaf miner, 100% in watermelons due to American serpentine leaf miner, and 30% in muskmelons due to vegetable leaf miner. If you are currently looking at the PowerPoint presentation, we are on slide 5, assessing regional risk of exotic leaf miner. The first step in assessing whether you will be at risk of exotic leaf miner is to consider the likelihood these pests will be able to survive in your area. And to do this, the project considered the conditions in which these pests can survive based on laboratory data, along with the environmental conditions the pests would encounter across Australia using climate data. From models developed throughout the course of the project, we found that most of the northeast coastal regions of Australia could support populations of vegetable leaf miner throughout the entire year. This includes regions such as Bowen-Burdekin and Bundaberg, key melon growing regions. In contrast, we found that in the key melon growing regions of northern Australia, the climate is only suitable for the vegetable leaf miner for about half the year. It will be important to consider not just the seasons during which the pests may flourish in your area, but also how this overlaps with the presence of susceptible crops. To do this, you can use a new interactive web tool to compare regional risk of vegetable leaf miner with crop seasonality. A link to this tool is available at www.ozveg.com.au/MT16004. The next question we have to ask: what is the risk that exotic leaf miners spread to my particular area? There are many different spread pathways by which these pests can travel. Larvae and eggs may be transported on cut flowers and plant material, pupae can be carried in the soil, and adults can hitchhike via tourists and in machinery. There are also natural pathways including wind-assisted transportation. However, for these small flies, the major pathways tend to be human-mediated. Thus, growing regions nearest to dense human populations will be at the highest risk of initial incursions of these pests. The rate at which these flies can spread will also determine how quickly we must act to avoid mounting economic impacts. We combined our knowledge of where the vegetable leaf miner could survive, how it could move around the landscape with the help of humans, and the value of production regions it could reach to predict how the economic impacts could grow within a given location. We found the regions of Bundaberg and Bowen to be at particularly high risk due to their high climate suitability, proximity to dense human populations, and high production values. Economic impacts could reach the millions within the first 2 years of the pest establishing there, if it is not appropriately managed. It will be particularly important in these regions identified as being high risk of economic impacts to be proactive in their surveillance. This will ensure the pest can be detected early and appropriate management undertaken to avoid outbreaks. For that, Elia will cover some tips for surveying for exotic leaf miner and discuss some important points regarding appropriate management for these pests.
Thank you, Maddie. My name is Elia, and I'm going to share some information about how to survey for and ultimately manage exotic leaf miner pests. And we're on page 10 if you're following along in the slides. Surveillance is, of course, a very expensive and time-intensive activity, so we want to use any information we have about the behavior and ecology of these pests to try and make sure our surveillance is as targeted as it can be. So what we can do is consider the what, when, and where of surveillance. In this case, we know what to look for, and that's the persisting leaf mines that you find on leaves. They tend to be much easier to detect and last a lot longer than the small and short-lived adults. As far as when you should be looking, you want to focus in on times of the year that are at the highest risk for the pest to flourish. Those are periods when surveillance will be most efficient. And you can use that interactive risk tool, which Maddie mentioned, to explore your region's predicted seasonality of risk. And when considering where we should focus surveillance, we can think back to the most high-risk pathways for these pests to spread, namely human movement with some potential for natural dispersal on the wind, and this tells us where on our farm we should be focusing surveillance. And that includes transport routes, unloading areas, anywhere where there's a lot of incoming traffic, and also areas on the incoming wind side of your farm and paddocks. Surveillance for these leaf miners should always include broad-leafed weeds, in particular if you know a preferred weed is present. For example, the most favored weed of vegetable leaf miner is cilantro, and that's a weed in the bean family which is distributed really widely across particularly the northern half of Australia. While you're surveying, keep an eye out for leaf mines and stippling damage on the upper surfaces of leaves, and if you travel at a pace of about 1 meter per 10 seconds, you can maximize your likelihood of spotting a small amount of leaf mine damage if it's there. And that's because the slower you travel, the more likely you'll actually spot a leaf mine, but the less likely you'll cover enough ground to detect a small isolated patch of leaf mining activity. There's actually quite a large amount of experimental work that went into creating such a recommendation, but I don't have time to go into it. But you can find out more at the OzVeg website, which Maddie will share again at the end. If you do see something suspicious as you're surveying, take a photo and record a GPS point right away, and then take a sample of the damage. And this is as simple as picking the leaves, which bear those leaf mines, and placing them into a sealing plastic bag. Then immediately report your find to the Exotic Plant Pest Hotline, and that number is 1-800-084-881. This will put you in touch with the Department of Primary Industries or Agriculture in your state or territory. Now, whether you find something or not, it's always important to record your surveillance results. In particular, you should note how much area you covered and how much time you spent there, as this allows an estimation of the confidence we could have that you would have seen some damage if it was there. And that sort of information is really useful in the event that these pests start to spread and your area is involved in an application for pest freedom designations. So why do we actually want to collect a sample? Unfortunately, you're going to be unable to determine if a leaf mine you're looking at was caused by an exotic leaf miner or by one of the many native and naturalized species that we already have present in Australia. And if you're looking at the slides, you can see some pictures on the right of a whole bunch of different leaf mining damage, and only that central square is caused by an exotic leaf miner fly. So you can tell that the damage created by a lot of these flies is pretty much indistinguishable. And not only that, but even some of the adults of these native flies look identical to exotic leaf miner adults. So therefore, we have to rely really heavily on molecular tests that can distinguish these species. We also often find empty leaf mines more often than we find mines that contain a fly which we could run a DNA test on. So our project developed a new molecular test that can actually pick up the really trace amounts of DNA that a fly might leave behind after it's left a mine. And that allows us to identify the species that used to be present. So when you collect a sample, this means that biosecurity officers could still potentially quickly determine the culprit even after the fly has moved on. Following those tips can help ensure that we're going to be able to detect these pests early should they start to spread, but it's equally important that we're prepared to manage these pests correctly right from the get-go. And so it's really important to understand a few things about the ecology of these pests. Exotic leaf miner are a secondary pest. That means they're actually rarely a problem in a natural system, where they are held in check by their natural enemies, which in this case are tiny parasitoid wasps. However, what's happened time and time again overseas is that in an attempt to manage these flies or to manage another pest in a system, non-selective insecticides are applied, and these wipe out the communities of parasitoid wasps because these wasps are extremely sensitive to chemicals. The leaf miner flies, on the other hand, can be very difficult to control with chemicals because the larvae are protected inside the leaf, and they can also have really high rates of chemical insecticide resistance. Thus, you get the destruction of the beneficial wasps, but not the flies, and the fly populations become free to grow rapidly, released from that natural control. And this is indeed the situation that has been universally associated with high economic damages reported overseas. This is the scenario we want to be familiar with so that we can avoid it right from the start. But we're really lucky here in Australia because we already know what appropriate management of exotic leaf miner looks like. There's been decades of learning overseas that has led to the creation of highly successful integrated pest management programs that avoid these secondary releases. And these programs have three core foundations. First, we must understand the role of these parasitoid wasps. Second, we must have a way of monitoring pest and beneficial activity and relying on economic thresholds to reduce and delay our pesticide sprays. And finally, we must avoid broad-spectrum insecticides to make sure we're not destroying parasitoid communities. And you also have to consider not just what is targeting the leaf miner, but what is targeting other pests in the system. So in anticipation of developing IPM programs for exotic leaf miner in Australia, our project began researching the potential for Australia to rely on natural control of leaf miner by parasitoid wasps. So let's start there. What is a parasitoid wasp? These wasps are really tiny. They're only about 1 millimeter long. They couldn't sting you if they wanted. They're instead focused on finding leaf miner flies, which they sting, feed on, and lay their eggs inside or on. And they're generalist species, which means rather than only eating one specific species of fly, they will actually attack anything that mines in leaves. So that means there is potential that the parasitoid wasps we already have in Australia might even be effective against these new exotic leaf miners should they arrive. The life cycle of these wasps is really cool. It's right out of the movie Alien. The females will find a leaf miner larvae inside a leaf. She'll use her ovipositor to inject an egg either right next to or inside of the fly. For some species, that fly gets paralyzed right away, the egg hatches, and it starts eating the larvae alive before emerging from a leaf mine as an adult wasp. And for other species of wasp, the egg actually lays dormant inside of the fly larvae. The fly continues feeding and growing, but as soon as it pupates, the egg is triggered, it hatches, and the wasp consumes the fly from the inside, before emerging from an otherwise healthy-looking fly pupa. And it actually is quite important to understand these life cycles, as it helps you know how to monitor for parasitism activity, and I'll come back to that. We know that overseas there's at least 70 different species of parasitoid wasps that attack vegetable leaf miner. And we are really in luck because some of the most important species, even some of those which are mass reared for release overseas, have already found their way to Australia. And so in addition to these tried and tested species, we also have our own native parasitoid species, which have already been attacking our native and naturalized leaf miner flies and are very likely to hop onto the new exotic leaf miner flies if they do arrive. And some of these species that we already have in Australia have already begun to attack vegetable leaf miner flies as they have started to spread down through the Torres Strait and into the far north tip of Queensland. So at the end of the day, we're in a really great position to not need to import any species to allow good biocontrol of exotic leaf miner. We just need to ensure we're protecting these wasp communities we already have so that they can do their job and control these pests. This brings us to that second core foundation of an IPM program, which is to monitor leaf miner and parasitoid populations to ensure we're not applying a chemical when natural control is already working. And while I don't have a lot of time to discuss this, the most important thing to remember is that just because you see a leaf mine does not mean you're looking at an active leaf miner population that needs managing. They could be old mines, they could be mines full of wasps instead of flies. And there's some good tips that have been developed overseas for monitoring, and if you want to learn more, you can access a management guide at the AusVeg website, and Maddie will remind you of the link at the end. So now let's consider our third foundation of an IPM program, which is the selection of appropriate chemicals, and we're on page 21 if you're following along. First, we considered the efficacy of different chemical options used overseas for control of leaf miner. And because leaf miner larvae develop inside the leaf, it's important that we use a pesticide that's actually able to reach these larvae, and that means translaminar and systemic insecticides are more suitable than contact insecticides. Next, we considered toxicity to beneficials, because we want to be able to conserve those important wasps, so we reviewed toxicity of commonly applied chemicals to the parasitoid wasps of leaf miner. And chemicals like cyromazine and abamectin are less disruptive to wasp communities than things like OPs and SPs, which should be avoided. Next, we considered the likelihood that leaf miner might evolve resistance to these insecticides. And that has certainly happened overseas. Exotic leaf miner species show a great deal of insecticide resistance, meaning it's going to be really important we do have multiple modes of action available in Australia. And finally, we compared the best looking of those chemicals based on those categories to what was already labeled for use in Australian crops, and at what rates to determine which ones we were most likely to be able to secure permits for the control of exotic leaf miner. And this led us to 6 chemicals that we have now either extended or secured a permit for across a variety of crops. 2 of those, abamectin and cyromazine, are available for control of leaf miner in melon crops now. Both have translaminar properties. Both are used overseas at rates that will generally not cause residue issues in Australia. Cyromazine is least disruptive to parasitoids, and both these chemicals come from different modes of action groupings, which will be important to give us the option of rotating to reduce the risk of insecticide resistance. These and any other permits developed in the future can all be found on the APVMA permit database if you search leaf miner or Liriomyza. So that should give you a good general understanding of what correct management will look like for these exotic leaf miner, and it will of course have a heavy emphasis on promoting the activity of our parasitoid wasps already present in Australia. And this is why targeted surveillance is going to be so important, because it increases our chances of detecting these pests early before they really start to spread, and that allows us to make sure we don't accidentally disrupt our parasitoids right at the beginning, giving these pests a chance to flourish. So with that, I'll pass back to Maddie to wrap up. Thank you.
Thank you, Elia, for providing such an engaging discussion on surveillance and appropriate management for these pests should they ever establish in Australian production regions. As Elia has mentioned, we have developed a number of project resources, including an industry preparedness guide and an industry management guide. These guides, as well as several other resources developed throughout the course of the project, are accessible via www.ausveg.com.au/MT16004. Alternatively, you can contact Elia via her email address epirtle@caesaraustralia.com, or Maddie via her email address madeline.quirk@ausveg.com.au. Finally, we would like to acknowledge and thank our numerous project partners and collaborators, without whom this project would not be possible.